So welcome students. So now let us look at the topic of function. So function is one of the most important topic of your class 11th and 12th syllabus. And this topic is an extension of the topic of relations. So you have already seen what a relation is. So what is a relation? A relation is some sort of connection between elements of the first set and the elements of the second set. That is, you connect some of the elements of first set with some of the elements of second set. That is, assume that 1 is connected to B, 2 is connected to D, 3 is connected to A, so on. This is a sample relation. So this can be called a relation. This is a subset of the Cartesian product of A and B. So the Cartesian product of A and B contains all the possible arrows between A and B. And out of all those arrows, if you select some of the arrows, it becomes a relation. Now, what is a function? A function is a relation which satisfies certain conditions. A relation which satisfies certain conditions. So let us look at what the conditions are and what are the conditions to be satisfied for a relation to be called a function. So the conditions are something like this. The first condition is every element in the first set has to be connected with elements in the second set. That is, you should not leave any elements in the first set. So no element in first set, set 1, can be left out. So in a relation, elements in the first set can be left out also. That is, this is also a relation. But this is not a function because the first condition that has to be satisfied is each and every element in set A has to be related to an element in the second set. So I cannot leave any element. That is, 4 should also have an image. Right? So 4 should also have an image. All the elements have to be mapped. And the second condition is that every element of set A should be mapped with one and only one element in set B. That is, every element in set A has to have a unique image. So these are the two conditions. If satisfied by a relation, it can be called a function. So what is the first condition? No element in set A can be left out, and every element in set A should have only one image in set B. So there are two problems. So one is, if an element is left out in the first set, then it is not a function. Otherwise, if an element in the first set has more than one image, assume that 1 goes to B as well as 1 goes to C. That means 1 has 2 images. So this is not a function. So if a relation should not be a function, it might have two problems. First is, if some elements of the first set are left out, then it is not a function. And if any element of the first set has more than one images, then it is not a function. An element in the second set can be left out because I am not talking about elements in the second set. So if you want the function, if you want the relation to be not a function, one of the things that you can do is, if 1 goes to more than one image, then it is not a function. And even if all the other elements have only one image, if at least one element has more than one image, it's not a function. Otherwise, if I left out some number, assume that all the other elements have a single image, but 4 does not have an image. So this is also not a function. So if it has to be a function, it should be something like this. 1 is connected to A, 2 is connected to B, 3 can be connected to B, there is no problem. 4 can be connected to C. This can be a function. Because what is the first condition? Every element in set 1 is connected to an element in set B. And the second condition is every element has a single image. Every element has a unique image. That is, the image of 1 is A, the image of 2 is B, the image of 3 is again B. You have a single image. The image of 4 is C. So every element has only one image. Two elements in set A can have the same image. There is no problem about it. But single element in first set cannot have two images. Right? So again, another example of function is 1 goes to A, 2 goes to D, 3 goes to C, 4 goes to E. This is also a function. So first, I hope you have understood the basic definition of function. So these are the two conditions. If a relation satisfies, it becomes a function. Now let us go forward. So, a relation R defined from set A to set B is called a function if and only if every element in A, that is every element in first set, has one and only one image in B. So I can combine those two conditions in a single sentence. So a relation is called a function if every element in first set has one and only one image in the second set. So this is the definition of function. And the things that you need to remember is two or more elements of A can be mapped to a single element in B. There is no problem with it. That is, 1 is mapped to A, 2 is also mapped to A, 3 is also mapped to A. There is no problem with it. The only condition is every element in the first set should have one and only one image in the second set. And some elements of B can be left out. So if you have this B which has been left out without any connection, so there is no problem with this, because the definition of the function only talks about the first set. So what are the two things that can happen? More than one element in the domain in the first set can have a same image in the second set, and the elements of second set can be left out. There is no problem. So now once you understand the definition of relation, so again you have terms domain, codomain and range. So you have these three terms. So if a function f is defined from A to B, usually functions are denoted by f's, relations are denoted by r. So usually functions are usually denoted by the letter f, and relations are denoted by the letter r. So if a function is defined from set A to set B, the set A is called the domain of the function, because we know that every element of the first set will be mapped to at least one element in the second set, right? So all the elements in set A are covered. So you don't need to look for only those elements which are connected, because every element of A is connected. So directly the first set will be the domain of the function, and the second set is called the codomain of the function. So a function is defined from domain to codomain. And you have a third term which is called range. Range is the set of those elements of B which are mapped to A. That is, this is the set of images. So range is the set of images. So for example, if you take this set, so the domain is nothing but the set 1, 2, 3. That's the domain of this function. What is the codomain of this function? Codomain is nothing but the set containing A and B. The set containing A and B. And the range is the set A, because only A is mapped to some elements of A. B is not mapped, so B does not come in the range. So B comes in the codomain, but B does not come in the range. So I hope you have understood what domain, codomain and range of a function is.